out, and so I'm going to have a letter or two for you as well. But I gave letters out because in AB today, I gave letters out because they're getting their limits test back. And from 20s to hundreds. It was rough. It was rough on some. They do get to do corrections for half credit back, but if any of you know any AB kids, get some tutoring hours and offer to help them with corrections and like give them advice, like help them out. Remember your first non-pre-cal test? Pre-cal, remember the multiple choice weren't really tricky, like there was a right answer and then there were a few that were kind of like it, but they were obviously wrong. What's different with calculus multiple choice?
They're very, very tricky.
I try to trick you because they will try to trick you, right? So every single answer can, well, almost every single answer can be gotten from some version of solving the wrong way. So, and of course, one the right way. So anyway, please, 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 just encourage them, help them. I gave them a huge pep talk. I gave them letters before they ever saw their test. They're getting half back on their test corrections, but if you know an AB kid, just go give them a hug and be like, you can do this.
Corrections due Friday?
For the end of the grading period, so anybody you know. And some of them, and I told them, like, if they got above the 75, I was really proud of them, and if they got below, like, we can work on this, and it'll be okay, but you might want to ask them, do they really want to do this? But at the same time, like, you know it was really hard the first one, so yeah. Anyway. Here we go, number 72. Come on, we all know this. Derivative of tangent outside?
Oh, that's secant tangent.
Nope, that's not it. What?
No, it's
E.
It's E.
What?
I saw A and I got confused. Derivative of tangent is secant squared.
I'm a schmuck.
What is the derivative? Who has a derivative of secant tangent? Secant.
I don't know how I made that jump.
It's okay, I circled the wrong one. Number 73. Which of the fall? Hold on, how'd you do it?
Derivative of 2. So
Don't get tricked by the trig notation because cosine squared is the same thing as the whole thing squared, yeah? So bring down the 2, we keep the cosine of blah 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 blah. Then we multiply by sine of the blah 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 blah. We put a negative in front, and then we multiply by
3x squared plus 2x.
blah 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 blah. I don't know why I have an extra parenthesis. Blah. There we go.
Wait.
And then we can go ahead and combine stuff. It seems like they keep the negative 2 on the outside. Oh, maybe there's not much combining. We can move that to the front. I see a cosine blah and a sine blah. Looks like C, huh? Number 74 and 75. Hey, it's new stuff. The parametric equations. 74 says, which of the following is an equation of the tangent, front row. Got to find our derivative such that t equals 0. How do we find derivative of parametric?
Derivative.
Y prime, x prime, who's on top?
Y prime.
So y prime is going to be cosine of 0. True? Is that okay?
Yeah.
And then, is that t?
Yeah.
Yes. 1 plus sine of 0. Cosine of 0 is? 1. Sine of 0 is?
0.
So 1 over 1 is 1. Oh, well, that's fun. But hold on, wait, we're not good enough because that's just the slope, right? The slope of the tangent? So how do I find a point? Well, I already know that I have 0. And what's the other point going to be? Uh-oh, 0 is who?
That's t. Yeah, you scared me.
So, whereas normally I could say, hey, that's the x value, that's not the x value, that's the t value. I need to find x and y dependent on 0, right?
Yeah.
So then x of 0 would be 0 minus cosine of 0.
Which is 1. Negative 1.
Woo! And then plugging in 0 to the next one, sine of 0 is 0 and negative 1. So then I have y minus a negative 1 or y plus 1 equals 1 times x plus 1.
And then subtract the 1 over. The ones go away. Y equals x.
Dun, 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 dun. Are we okay?
Yeah, I don't know why, but I put T in for this point
Common,
slope.
right? Common mistake. Common mistake. Number 75, last one. At which of the following values is dy dx? Was dy dx without something plugged in?
Cosine of t over 1 plus sine of t.
And if I need this to equal 0,
You said the top.
I set the top equal to 0. We call it a pitchfork Gerardo just because of critical numbers. We'll get back to that in the next chapter, chapter 5. Top equal to 0 are zeros, bottom equal to 0 are undefined. Just something silly.
That's a rational function.
Mhm.
Why didn't I?
It's okay though. When does cosine equal 0? Which of the following? Well,
Pi, 2
cosine
pi.
is 0 at anything that's a half pi, right?
Oh.
So the only half pi is
Wait. What?
Because if you plug in
0, 1.
close,
Cosine
you get a
is
number.
0.
When does cosine equal 0?
At pi over 2, 3 pi over 2.
So it'd be cosine of t equals 0.
Yes.
With cosine inverse of 0.
Pi over 2.
What? Oh!
When is there you go. We got it. Alright, kiddos. Technically, real quick, this is an endeavor card, and I meant to have it so I could be like, look, all of your endeavors, and we're good. And then I was grading BC and AB and honors pre-cal and regular pre-cal, and then some test corrections this weekend. So, and making your notes. And your entire chapter homework is all updated online.
That's great.
Yay!
Now we have no excuse.
So anyway.
for homework.
Yeah, no excuse at all. So anyway, I was telling Gerardo earlier, I will try to have all your endeavors ready to go. But let's just real quick, hold on, pause, real quick. You guys tell me from what you did over the weekend, what is the first derivative? How do we find it out of a parametric equation?
Y prime of t over x prime of t.
Good. And how do we find the second derivative parametric
Y
equation?
prime.
d dt of dy dx over x prime of t.
Does that make sense?
Well, when you explain it, it does.
Did we practice that over the weekend?
Yes.
Do we hopefully have it
No, we
solid?
didn't do the double.
Yep.
We didn't do some double.
Oh, I have a. Oh, never mind.
Stink-a-dink. I thought I found one or two. Oh well. Kiddos, I do want to go over homework number 10, but since it's a chapel day and since we did letters and all that jazz, can we just zoom into 4-2 and we'll go over evens of everything tomorrow? If you guys have further questions, feel free if you want to ask something before tomorrow. But let's just check both homeworks tomorrow because I want to go ahead and get into implicit differentiation.
That was fun over summer.
Implicit differentiation. There are only 4 sections in chapter 4. I was going to pair up some days, but actually our book tends to cram random things in at random times, like the derivatives of parametric last section, which is good. It's great. We need to learn it. But it is a little random in its placement. However, not really, because they were teaching chain rule and parametric deals with chain rule. But anyway, all that to say. All that to say. I want to take a whole day on each of the sections, which means, give me 1 sec, George. 4-2 will be 1 day, Monday, Tuesday 4-3, Wednesday 4-4, Thursday review, Friday test. Then I can grade it quick, put it in for the end of the grading period. George, go ahead, bud.
Did you say we were getting test back today or not?
Yeah. You guys haven't noticed, I haven't exactly started stars this year.
Oh,
It was a pain to get off the, I don't know, I'm trying to think of something else to do. Yeah.
What do you mean?
They were trying to pull them off and having a contest who could pull off the most stars from the
I
line.
think I won, but I didn't.
I technically was there when she counted, so as long as she counted correctly.
But I don't know what she did. You're in cahoots with her.
What?
Well,
So are you.
she does help you out a lot. I mean,
Exactly.
she even helped
Not
out with
this
track.
year. She's busy.
She helped you with track last year.
She was waiting to talk to Sheldon. Mr. She. Hi.
Do people call him by his first name?
Yeah, I know those little mistakes, bud. You gotta stop being on those. But everybody made little mistakes somewhere. No over hundreds this time.
Oh, at the main one again? That was rough.
What's this one?
Oh, sick first grade.
Wow, these are honestly the 2 stupidest mistakes ever.
I know. See, that's what I said. We have to stop you guys. You know a lot, but we have to polish so that you
Doesn't make sense.
always show me.
Negative 400 minus 2.
Wasn't it a vertical tangent?
No, it was C. I'm so stupid. Oh, that was the same mistake I made on the quiz.
No, remember.
Same mistake on the quiz.
But like, aren't they all discontinuities? I thought like it couldn't be that one because they're all
The
this types of.
derivatives have a discontinuity.
Oh, that's what I meant.
Yeah.
I was like, they're all discontinuities.
Yeah.
Like,
Oh,
that's just like.
On this one, positive side? Would it be a positive on the bottom?
But the original function is discontinuous. So you're not looking at the derivative. You're looking at the original.
Number 18, I knew.
The other ones, and actually, quite a few of you guys missed that one. On number, what was that, 3? 4? On number 4, remember, a corner, a cusp, is an existent point of the original function, which means the function is continuous, but there's a corner, there's a cusp. The derivative does not exist for some reason other than the function is discontinuous, but that function is a vertical asymptote. All right. How do we take derivatives of implicit functions? We take the idea that v dx of some function of y is equal to what? How do we take the derivative of a function in terms of y or a function with y's? When we're taking the derivative with respect to x.
Y prime.
F prime of y times y prime. Or another way of looking at it is f prime of y times dy dx.
Why is that?
Because derivative of the outside, f prime, keep the inside, times the derivative of the inside. If this was f of x, derivative of x prime is just 1. Derivative of x is 1 when with respect to x. But when we have a y, y prime, oh, that's dy dx.
Oh, you want it in terms of x, but you have it in terms of y.
Exactly. Which is the same idea as the ones with t's. George.
Why is the top one implicit on the left?
Because the way it's written, y is not by itself.
Well,
Doesn't mean you can't find y by itself. But the way it's written, y is not by itself.
Is it that we want the derivative of x, but we have a y mixed
The
in?
derivative with respect to x.
Yeah.
And we have a y mixed in, yes. Yes. So, long story short, from our book, we want to differentiate both sides of the equation with respect to x. Hence, the way I show it is take d dx of both sides. And similarly, not really. I'm just doing a quick review in the way our book shows it. Collect terms with dy dx. There might be more than one. So get all the terms with dy dx on one side, factor out the dy dx, solve for the dy dx, and hopefully you are done. dy dx can be implicit as well or explicit. If it's a multiple choice question, you have to check it out. Did they get it all in terms of x, or did they leave some x's and y's in there? It just depends on how they solve. Some problems are near impossible to get only in terms of x. Some problems are more possible, so maybe we'll do some plugging and chugging. So let's go ahead and... No, I'm not ready yet.
Yeah, I am actually gonna write this down.
Skip a few lines maybe? Oh, here, I'll dual page it. That's what we do.
No, because I'm not gonna have time to go back to it last night.
So what do we do if it says determine the slope of 3x squared plus y squared equals 100xy? Woohoo! Okay, what do we do? ddx both sides. And when we ddx both sides, you can think about it as ddx of the entire thing, if that helps. This one's a little rough. The derivative on the left, that's definitely a chain rule, but it's actually a chain rule within a chain rule. But how do we take the derivative of the left? Bring down the 2, right?
X squared.
Keep the inside, x squared plus y squared times derivative of x squared.
Plus 2y
Uh-oh.
dx.
With 2y, take the derivative of the outside, 2 times y to the 1 times derivative of the inside, hence dy dx. You can say y prime. I don't do y prime because I think it's too easy to confuse. But some of you might want to do y prime, and that's okay. Derivative of the other side, one of the most common mistakes. 100.
Y.
100x dy
Y.
dx.
Second d first. Is that what I did?
Oh, my bad. Yeah, second to first.
Second d first plus first
dy dx.
d second. Does that make sense? And then technically we have to go ahead and get all the dy dx's on one side, right? To isolate. So you end up with 12x, x squared plus y squared minus 100y equals 100x minus 12y x squared plus y squared. Hold on.
You pulled it up.
What did I do?
Impressive.
Sam was in it too. But I multiplied 1. I said he doesn't have a dy dx. Hold on, let's go get the other non-dy dx and subtract him over. Then let's go back and subtract over. Well, first I stole him. 100x dy dx. And then went over in here and got him 12y times blah 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 dy dx and moved him over. Then I can go ahead and, yeah, George, definitely don't get everything in terms of x this time. So we'd have 12x, x squared plus y squared minus 100y, all over 100x minus 12y, x squared plus y squared. Could you pull out like an even number top bottom? Sure, why not? But let me see what's coming in.
No, I'm gonna plug in.
Plug in what? 3, 1. Okay, let's hold on. We did have a little too much time with letters today. However, the only thing we missed was the second derivative. And we're going to have this one as a warm-up tomorrow. So if you don't remember how to do the second derivative, I think that's one of the most common mistakes of AP students on the AP exam. I'll go ahead and work out this example for you guys as you leave. Sound good? Which you need to say done.
All work still do tomorrow, yeah?
Oh my
Yeah.
gosh, that was so
We can do this.
See, you're still recording.
I know. But for Joyce, I figured she probably won't spend as much time on the letters as we did.
Yeah.
3, 6
I should be doing
times
this.
I'm gonna
9
feel
plus
this.
1 is 10.
Do you even know what the picture looks like?
100
Yeah.
all over
It makes sense.
Well, there we go. At least you guys have it.
times 10 again.
That's
right?
one thing I'll get right.
Hi, kid. 360 minus 160. Bye, guys. Have fun on your Bible test.
You left my car,
Alrighty.
you don't like me.
And then we can go ahead and reduce with our zeros, and then 26 over 8 will give me 13 ninths.
Yeah. I put all the graded ones on.
Yeah.
You get 2 ideas because you why? What? Slow. It's essentially to get past what's derivative. Why? But you don't have.
You're lucky, I want to
So when
be.
we take derivative
No, I was at my dad's house.
times
Make it easy.
is 1 because it's dx dx. This one we take the derivative of 2y times y prime, which is dy dx.
Because it's you're squaring the function of y. So like it's instead of saying
That's what I did.
instead of having this in terms of x, given in terms of y, so it'd be like having 3x plus 1 equals y, but it's a
And we
quantity
always
squared.
did that when we had y equals, we take the derivative. We messed up. I already knew it. We did that.
There's more in the trash.
So it'd be like 3x plus 1 quantity squared, but it says y. Right.
That's the way I think about it.
How old are your brothers? Oh, yeah, that's good. That's really good.
You gotta put them back in the recycling. Put it in the trash.
It's my pancake. Go with me.